All right, so welcome back. This is lesson one for spring of 2022. We're covering double number lines. Your students have been in school for 2 to 3 weeks, so they've already started some proportional reasoning with their teachers at the school sites. So we're coming in near the end of a lesson. So if your students have some background knowledge, great. But I just want to make sure you know we're not starting them off from scratch. Again, their teachers will have some time with them. Also, I want to recommend that, well, you're going to have to turn in your answer key for your documents. So before I even make my video, I went through and I worked out all the problems to think of what could go wrong or what could go right. And I have to have that here to help guide me through the lesson. So, for those of you who may not have been creating your self answer keys, we are going to ask for those this semester just to help us streamline things and make sure you're all good to go with the material. Also, you're going to upload these things as evidence that you completed the training, and you're going to participate in a discussion post. In the discussion post, we're going to ask you to create your own example problem and share it with the group so that the group then has a whole bunch of examples that they can pull from to create additional problems for their 2Ds. All right, so here we go. Your document is going to look like this. If you want to come and pick one up, I'm going to try to put them outside of the door. I'm in Headington College, room 132. And yours are going to look like this, where they have the links here as well when I upload them. But the ones for the students won't have these parts, okay, these little notes. They're going to be deleted so that you can help them write a little bit of notes before they get started, okay? So, technically speaking, you've already taught your students about proportional reasoning whenever you worked with equivalent fractions. Okay, so if you want to tie it back to equivalent fractions, you can talk to them about 2/3. So here's my 2/3. Sorry, I gotta make sure I stay on the screen here. There's my 2/3. Okay, and I want to know how many sixths it would take to be equivalent. Okay, so I have my sixths here, and I'd say, oh, 2/6 are equivalent to 1/3. So then 4/6 are equivalent to 2/3. And I can see this because if I do 3 times 2, I get the 6. And if I do 2 times the 2, I get the 4. Okay? So these are equivalent. You need to make sure you're using that terminology because when they see that in questions, they ask what equivalent means. Yes, it's similar to the word equal, okay? But equivalent means like worth the same. They might not look the same, okay? If you want to use these tiles, you can check them out again whenever you swing by on Tuesday. So feel free to pick up a package, but you only need one. No matter how many people you have, you can kind of do it together. Okay. Then on the next one, either you can model it with the tiles again, or you can say through multiplication or division, what would I do to a 2 to become a 4? Okay, well, I could do 2 times 2, and that would give me 4. So to create an equivalent fraction, I would have to say 4 times 2 and get an 8. Again, if I want to model this with my fractions, 2/4, and then I have my eighths. You could even do this as part of your warm-up time that day so that students can get back into the groove of things with using manipulatives. All right, so proportions are really just equivalent fractions, and they build off of that idea. The students oftentimes will also use something that they call the butterfly method that somebody at some point in time taught them. Okay. And in the butterfly method, what I often saw when I was in the classroom was students would say, oh, yeah, it's something like this. And they would just circle real quick and make this X or butterfly, and they would have no clue what to do with it. In reality, what they were supposed to do was 6 times 2 is 12. and 3 times x or question mark would be 3x. And then they would have to divide, and they would get 4 equals x. Well, that's great, okay? But it actually takes me more time to do that than looking for a common value to multiply or divide by, or actually using this double number line, okay? So if your students ask you about this, yes, it's something they've learned, but we want to go over an additional strategy that students could use to reason through proportional relationships. And these are especially helpful when you're using word problems. Okay, so here we go. A double number line is a way to organize information to help students see relationships between quantities in a proportion. The zero on each number line must align vertically, and 3 of the 4 quantities, you see there's an A, B, an X, and a Y, should be known. Okay? There's a first quantity and a second quantity. So if we look at this first problem, okay, it says Jovi is maintaining a campfire. She has kept the fire steadily burning for 10 hours with 15 logs. She wants to know how many hours she could keep the fire going with 9 logs. So first you want to have the students identify the information that they're talking about. Well, they're talking about hours and logs. We then have to identify the starting value, which is 0. Okay, I'm going to switch to my pencil so I can show you what's going to happen and how we need to go from here. If you read the chart, it says that we need to know 3 of the 4 quantities. Okay, well, normally I would have started here and I would say, okay, well, I know then that 10 hours, we're going to use 15 logs, and they want to know how many hours, so that's going to be my question, with 9 logs. But then, oops, what do you notice? As we're working our way across here, our number line would never go from 0 to 15 to 9. So we need to make an adjustment there. Okay? And let your students do it this way first. Let them realize that they need to see if their values are getting larger or smaller, and eventually they'll catch on, and they'll be able to lay these out a little bit better. So I'm going to erase this. Also, you don't have to use the whole number line here. I just made some large ones, so if you need more space, you can. So I have question mark, 9, and 10, and 15. Okay. So what this is a way to kind of organize a student's thought, to see how many jumps or moves they could make, if they could half something or double something, to find out the values that they're looking for. So if we look here, okay, between 0 and 10, well, I could say that that's like 5, but then I run into an issue down here and I say between 0 and 15, that's like 7.5. Well, that's not going to help me to get to 9, okay? So how else might I break this up? Well, I know that 5 times 3 is 15. So I could go like 5, 10, 15. But that doesn't work out because I can't get to 9. Oh, well, what if I do it by 3s? So I could do 3, 6, 9, 12, and then 15. And it's okay if these are not perfectly even, because it's really a way to just think about things. And until they get used to using a double number line, this is what's going to happen. Okay. So then if I break these down, okay, and I have 1, 2, 3, 4, 5 sections, How can I break down my 0 through 10 into 5 sections? Well, I could do that as 2, 4, 6, 8, and 10. So notice then here, at 2 hours, I would use 3 logs. At 4 hours, I would use 6 logs. At 6 hours, I would use 9 logs. 8, I would use 12. And 10, I would use 15. So this is going to be where my answer is, because that's where my question mark was. Okay. The next things that students need to be able to understand is what the question was actually asking for and what answer they need to provide. Because what they'll see is something like A equals 6, B equals 9, and maybe even C equals 2. Okay. And the problem is that they don't know which one is which. So please make sure you stress the answer with the units. So the question was, how many hours could the fire keep going with 9 logs? So it could go for 6 hours. If you want them to write out a whole sentence, that's fine too. But they need to know it's 6 hours. All right. So now we're looking at option B. It says Mandy works construction. She knows that a 5-meter long metal bar has a mass of 40 kilograms. Mandy wants to know the mass of a 20-meter long metal bar of the same material. So what 2 units are we talking about? Okay, so we have meter and we have mass. Now, some of your 2Ds might say, well, which ones do we know that go first? Like, why did you put hours and logs? Why am I putting meters and mass? Usually mine has to do with the fact of how they're reading in order. The first unit comes first, the second unit comes second. But what I would recommend that you actually do is have one of your 2Ds work it out with meters on the top, mass on the bottom, and the other partner work it out the other way to see if they have a different answer or the same answer. This will just help them prove what they find out. Right? Every time I do a double number line, I have to start with 0. I then say, well, what information do I know? I know 5 meters is worth 40 kilograms. And Mandy wants to know 20 meters. Again, to help me set it up so I don't make the error like I did up here, I would say, okay, 20 meters is longer than the 5. So I think I should be okay saying 5 meters, 40 kilograms, 20 meters weighs what? And put my question mark. Okay. Now with this one, my brain might work it out differently than up here. Okay, where I was trying to find equal sections or how I could break it down. Instead, because I'm growing, what I might do is say, oh, well, if I go up by 5 more meters to 10, okay, if 5 is worth 40, then 10 should be worth 80. If I go up 5 more, 15 meters, okay, I need to say 80 plus 40. Okay, and then I could also go to 20. And then I add 40 again, and I get 160. So then that answers my question. I could have also done doubling, where here I thought of it, if I double this, I get 10. If I double this, I get 80. If I double 10, I would be to 20. And if I would double 80, I would be to 160. That's also okay. They don't have to see this 15, okay, for this problem because she's asking at 20. So my answer is 160 kilograms. I would suggest that you pause this. I can't pause me. And try to see. Okay. It says, what if Mandy needs to use a 3-meter long metal bar instead of 5 meters? How would that change the mass? So again, I would pause it and try this before you move on. All right. So for me, I would say the same thing here as meter and mass. I'm going to place my zeros. But now it's saying she wants to know about 3 meters long, not the 5 we've been given. Well, 3 is smaller than 5. So I'm going to put my 5 here. And I go, oh wait, I need more information. Got to go back up to the previous problem. Okay. 5 meters long was 40. Okay. Now it wants to know about 3 meters long. Well, I could half this and say 2.5, and this would be 20. Oh, I didn't make my markers. Sorry. Hold on. I need to know 3 in her question mark. Sorry. All right. So I could say I could half it and I would get to 2.5, and that would be 20. Well, that's not going to give me my exact answers. So this was when we have to think about how we might break this down into different values to have it make sense. I could also reason, though, that my answer for 3 should be between 20 and 40. So if I had any values that are less than 20, it wouldn't be the correct answer. So I'm going to erase my half because that doesn't help me in this case. And I'm going to say, well, it's only 0 to 5, so why don't I break it down by like 1, 2, 3, 4, 5. Okay. If I didn't break down 40 into 1, 2, 3, 4, 5, I can say 40 divided by 5. Oh, that's 8. Right? So I can make my sections counting by 8. So here would be 8. Plus 8 would be 16. Plus 8 would be 24. Plus 8 would be 32. So again, there's my answer. Okay. We have a 3-meter long metal bar, would weigh 24 kilograms. For some reason, it printed the answer part on the next page, so I'm going to write it there and put a box around it. Now, what you're going to upload, okay, for understanding of this content is you're going to complete the 1, 2, 3, 4, 5 problems on the back, okay, and I'm going to ask you to upload those to an assignment. I'm going to post these right outside my wall here. 132 is the office number, and just pick up one for now, okay? Because the one for your 2Ds is going to be a little bit different. I'm going to erase these parts on here so that you can have them write in the things they need to know about using a double number line. You need to make sure and teach these things, so you should walk them through at least 2 of them, okay, before you ask them to do it all on their own. You need to pretend like they've never seen these before in their life, okay? And act like you are the teacher when you're going through these first examples. Then as you have them work more independently, check in with them, make sure they're doing the information correctly, okay? Their examples might not look exactly like yours, depending on which one they put on the top line and which one goes on the bottom, but in the end, they should have the same answer. And you want them to be able to explain the process to you as it goes. If you have any questions about this, okay, feel free to ask. You can do that in the discussion posts as well. So either we can help you out, Mandy or I, or a classmate. And that's your lesson 1.